And question 5 is definitely a different looking question, but here we go. Student measured the heights, the arm spans and rounded to the nearest inch of each person in a random sample of 12 seniors at a high school, and we have a scatter plot. Based on the scatter plot, describe the relationship between arm span and height for the 12 seniors. Okay, so hopefully you can see that there's a clear positive linear relationship. So let's describe that relationship. When you describe a relationship, if you did this Khan Academy, there are 4 things you need to talk about. So the relationship of arm length, and I'm going to be really descriptive here because one thing you've seen over and over and over again is context, context, context. I've been being lazy and skipping that sometimes, and been kicking myself after I look at it again and I see context. So anyways, and height among the 12 seniors, just be really specific, appears to be, I'm going to say, moderate or strong. And it's linear, so it's moderate, strong. I'll say before linear, I'll say positive. I'm going to write it as a list. So I'm going to say moderate or strong because they're not totally close together, but I mean, it's also, you definitely wouldn't say weak. If it was weak, a computer detects that it's weak. You would just honestly say you don't think there's a relationship. So again, I'm going to say this is moderate to strong. It's positive and it's linear. Now what I'm also going to do is, again, I'm going to look at this trend line where I think it is. Now, if this is the trend line where I'm guessing, to me this point right here is definitely far below, and remember that that is what makes an outlier or influential point. It's how vertically far away any point is from the data point, or from the prediction line. So I'm going to say with the point, now I'm just kind of guesstimating here, but this looks like 69 comma x first then y, 65 being a potential outlier. Okay, so in general, if you're going to talk about a scatter plot, you need to talk about the strength, whether it's positive or negative, whether it's linear, nonlinear, or just non-existent, and whether or not there are any outliers. So you could just say with no potential outliers, or you could say with whatever one you think is an outlier. You don't have to call out an outlier, but I just think this one, you can see it in these other graphs. It looks fairly low compared to the rest of them, or at least it's the one that has the largest, what we'll call residual, which is the distance from the point itself to the prediction line. Okay, so what are these two graphs about? Let's read on. Let x represent height in inches and y represent arm span in inches. Two scatter plots of the same data are shown. So in other words, it's this scatter plot, same data, but one of them has a least squared regression line given by that, and one of them just simply models it with y equals x, which in other words is a perfectly diagonal line. So graph 1 is like the actual best, according to the statistics and math, best prediction line, and this is just an arbitrary perfect diagonal. So I mean, both actually look pretty good, but let's see what goes on here. Part B, the criteria described in the table can be used to classify people into one of 3 body shape categories: square, tall rectangle, or short rectangle. What a time. What is this even for? Well, I guess we'll get there. Okay. And then they give descriptions. So again, make sure you're just reading all the questions because you might sit here saying, what on earth is all this about? Well, just read the chart. Hopefully that makes it a little more clear. Okay, anyways, I'll say B part 1. For which graph 1 or 2 is the line helpful in classifying a student's body shape as square, tall, rectangle, or short rectangle? Explain. Okay, so I know the answer. But this is, again, this isn't even a stat question. This is an Algebra 1 question because this is the key here. How would you know if something was square, if your arm span was greater than or your arm span was less than? That would happen if you're measuring against a perfect diagonal. Because if something is perfectly on the diagonal, well then, x is equal to y, arm span is equal to height, and they're square. So if they fall directly on the line, they would be defined as a square. If your arm span is greater than your height, then that means you're going to be resting above this line right here in all cases. So 1 is the answer, and explain. So I'm going to say, actually, I guess it's graph 2. Graph 2 and explain. Since the line is y equals x, we can see clearly that if any point is resting above the line, or sorry, on the line, the associated student's body type would be square from there, any point above or below the line y equals x I'll say I'll write it like this. So yeah, for any, I'm gonna say it like this. Would indicate that, well, if you're above the line, then that means y is greater than x, or y is less than x, respectively. In other words, maintaining the same order, so above corresponds to this, below corresponds to this. I'll say which places the remaining students into the remaining categories. Hope I've defended this enough. Hopefully you can see what I'm saying here. I'm saying, gosh, and you know what, I gotta keep moving, so maybe I won't say what I'm saying. I'll explain later. Technically I have 15 minutes, I want to stick to it. So complete the table of classifications for the 12 seniors. So, okay, for square, let me go up here. There are 3. So this is for square. Again, because those are the ones that are directly on the line. Now, if your arm span is less than your height, then again, that means you're below. So how many are below? There are 4 below. It's like arm less than height. There are 4. What about arm span being greater than height? Your x value being greater than your y value, which essentially, wait, 1 minute. Oh yeah, never mind. I'm right. Okay. If your arm span is greater than your height, if you're above right here, again, because this one has an arm span of 62, but height is 60, so yeah, anything above, that's 5. Wait, there were 12. What's going on here? That adds up to 12? It does add up to 12. Okay, I'm just losing it because it's 1:30 a.m. Okay, we're done. Part C, and I've got 4 minutes to go. Again, hopefully you get what I'm saying here. Now, all I'm thinking is maybe there's a better way to phrase it. Of course there is, because the AP exam graders spent time figuring that out. But using the best model for prediction, which one's the best model for prediction? Does it say clearly? Well, the best model for prediction is the least squared regression line. Calculate the predicted arm span for a senior whose height is 61 inches. So that's going to be, we're going to call it, y hat for x equals 61. Now this is just a way of writing that you're clearly using the x value 61 and you're trying to use the prediction line. So that's going to be equal to I'm going to say approximately because it's a prediction line. And that's just simply going to be 11.74 plus 0.8247 times 61. And that's going to be equal to, well, we have 11.74 plus 0.8247 times 61, and that's equal to 62.0467. All right, and we might just want to round that up. Just bring some context into it since I have the time. Bring some finesse just in case that's has some thing left to be desired. So the predicted arm span for a senior with a way height 61 inches is 62.0467 inches. Done. Okay, let's score ourselves. Question 5. So they say moderately strong. Awesome, got that right. Positive linear relationship in arm spans between height and arm spans, so that taller students tend to have longer arm spans. So I guess I said the potential outlier thing. Maybe I shouldn't have said that. I don't know. But one of the things they also do is they kind of describe what that means. It means the taller you are, the longer arm span you should have. Okay. Graph 2 is the one that's helpful for each student on the graph. Illustrates whether arm span is equal to height. Point on the line. Arm span is greater than height, above or below. So actually, I got that pretty spot on. And I got my chart right. Hooray. And then my predicted height is 62.05. Okay. So the way you got your E here is by approximately linear, positive, moderately strong, and given context. So I did get context. Ooh, oh goodness. That was close. And they actually didn't say anything about potential outliers, so there you go. I would say either say it or don't. I don't think it's going to hurt you in this case. Okay, again, graph 2, give reasonable explanation of graph 2. I think I covered that. And then 3, 4, and 5. Okay, last but not least, correct formula for predicting arm span was 61, inserted for x, correct value for the predicted arm span, and units given in inches. So there you go.